Okay, all right. If you look at a bit like this, what number is this? Huh?
0.
Yeah.
The decimal.
What about this? What number is that? With no space here.
Nibble?
Yeah, but like if I told you what number is this, what would you tell me? I didn't say, did you say 0?
He did.
Okay.
Andrew.
Okay, yeah, so that's 0, right?
I think so.
Right, it is 0. But how are you going to know? I mean, it's 0, it's all 0, so it comes down to 0. But how are you going to know which numbering system am I using? Like, how are you going to know that?
The amount of digits you use. I guess the prefixes, like with the 0x or 0.
So if I do B, that becomes
it's 0.
Yeah.
So
that's binary.
Binary. And then what about if I did this?
Hex.
Right. And then if I did this, it's now just 0 decimal, right?
That's the one we're not supposed to use, right?
Yeah. Okay, it becomes octo. Yeah, you're right. It becomes octo. If I put zeros in front. And then this, I mean, 0, that's a decimal, right? And they're all representing the same thing, 0.
Mm-hmm.
So this makes sense, right? Well,
yes.
What about this? What number is that?
$255.
Yeah. 255, right? In decimal. What about your next? What's 255 in X?
0x, then 3 zeros in 255, or is it 4 zeros?
The way you do it is you split that one, right?
Oh, okay.
And then you go like the 1's place, the 2's place, the 4's place, and the 8's place. See what I've done there? See?
Yeah, 15.
Yeah, let me put it like that. And that's 8 plus 4 plus 2 plus 1.
Oh, okay.
See that? And that 15 in X is F, right?
Mm-hmm.
Because 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you start repeating again, right? And since you're repeating in decimal, you can't do 1 to 1. So you have, in order to make it a decimal, like here, it's gonna be 0, same number until like 9. But here, when you start repeating the decimal part, the other one you have to start using letters. Okay, any questions so far? those ones are just the same number, right?
Yep.
And this repeats until you're here, right? Cool. So whenever I did it this way, that's FF because you split them and then you put them together in X. Okay, now, so if I give you a number like this, I can also, okay, what's this? Let me just give it.
1, 2, 3, 4.
Okay, if I give you a number like that, that number is the same as, that's 8 plus 4. I mean, 128 plus 64 plus, since 32 as a 0, I'll skip it. So I'll just put a 0 there. And that's 16. 8, I'll skip it because it's a 0.
4.
And then the other one will be 4. And then 2, I'll skip it. And the last one is 1. So 21. What's the total here? That's 192 plus 21 something, 220 something. Do the math for me.
213.
Okay. All right, if it's wrong, but you
13, maybe.
Yeah, and the last one should be 15. Right?
Two, 1, 3 it is.
That's everything. Yeah. All right. Anybody confused about this part right here? Oh, you understand what I'm doing here? Okay. So we can come back to this. That's not the point right now. I just wanted you guys to be familiar with looking at the numbers. Now, so if I'm writing binary or X or decimal, I can interchange them in C, and C will treat them as the same. So it doesn't differentiate amongst the numbers. But the instructions that are given to us, these instructions, they actually have some stuff in it. If I gave you, you're gonna see numbers like this. In the instructions. And okay, yeah, you're gonna receive stuff like this. This one right there, it tells you it's got a special meaning. If you have like a 1 and a 0 here, that one tells you how many arguments you're gonna have, meaning how many steps you have to jump. And I think this one is also going to have a special meaning, but those meanings right now don't mean anything. So I'll just skip to what I wanted to talk about. But whenever that comes up, you will be able to look at a bit like this, and you'll be like, okay, this one is 1, so that means something. This one is 0, that means it's something. Just by looking at the leading two numbers. And the rest of them, you keep on learning as you go along. Right, so like those two, AA, number of operands for the opcode. The B, 1, if this is an LU operation. C, that location there. 1, if this instruction sets the PC counter. And the others, DD, those are the instruction identifiers. And you just keep on reading, and the first instruction we were told was print. So if we went to print, print as that. So print numeric value stored in the given register. Print to the console the decimal integer value that is stored in the given register. Machine code, that. So you're going to run that, and it's going to print whatever you stored in the operand A. Talking about that, let's do some code. The headers. Okay. So you did say to do, register the PC. You used unsigned char. Do you know the do you know what that means?
Unsigned, make sure it's positive.
Mm-hmm. Make sure there's no sign in front of it. Yeah. So that, and then we're gonna create an array with 8 slots in it. This one is the program counter. This one is an array, which is gonna hold the registers, like the 7 of them. Right now, we're only concerned with the first one and the second one. And then this is gonna hold the rest of the memory. And it's 256. All right, so pretty much if you followed that, you just have to follow the instructions. And that's the RAM of memory. All right. And then these LLU operations, those are like math operations. So we're just, here he has multiplying there. Yeah, we're just going to use that one. So that's okay. As you start adding more stuff, you're going to be adding them in here. Okay, and then you have load here. So what else do we need? We need the print, because that's the one we're trying to define. Do you know what the print is? We're also gonna need to stop the program. So there is the hot, and we know we need the multiply, right? Do you know what those are?
Print is 0, 1, 0, 0, 0, 1, 1, 1.
Okay. And then multiply?
1, 0, 1, 0, 0, 0, 1, 0.
All right. And then hold.
Multiplies MUL.
Right. But you're going to define all the instructions here.
Oh, yeah.
The LUL, you're going to put them in here. So the instructions are going to be working exactly the same, but how they do that is going to be changing as you go through the program.
Okay. And then the halt is 7 zeros and 1.
Yeah.
And it is HLT, yeah.
Okay, there we go. Okay, so we are doing that. Now we need we need a file because we are loading the instructions in here manually, but we need like to pick it up using a file. So we are gonna, whenever we are loading the CPU, like the CPU here, we're gonna kind of like, okay, do you know what this is right here? Do you know why we've written the functions like this here?
Yeah, they're in CPU.c.
Right, so we are kind of like predefining them and telling the compiler that expect these functions, right?
Yeah.
Okay. And in the load one, since we need a file, it's going to be expecting a file name, right? Okay, now that breaks it because we're expecting a file name. So the C1 has to receive a file name.
Mm-hmm.
No.
You gotta have the file name be a char in cpu.ht.
Right. Okay, there we go. What? Why is it done? Okay, there we go. Okay. All right. So we've defined the function, which is receiving that. All right. But we need to pass it in, like we need to get the file name, and then how are we going to get the file name? We're going to load it up in here, right? 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 Anybody?
Yes.
Okay.
Yeah. Yeah, instead of void, we want to pass it an argument count and argv.
And this can be like that, or you can pass it in like this. Same thing. And then you want to check if this argument count is more than 1, right? Or it's the correct count. And how do we check that? We just check the count, right? And since it's loading the execution file and the file itself, we'll just check if it's equal to 2. If it's not, we're gonna tell the user that there's an error in the usage. And that's not gonna work. And we're gonna use the standard error and explain to the user that use it by passing in the ls8 with file name. Like that. And then we can exit. And once we get it here, we can create a file name here, which we're gonna now pass to the, so you're gonna grab the first argument or the argument at index 1, and that's the one you're gonna pass to the load. Okay, what's that? Why the error is? Okay, so I'm using exit and all that. Those belong in the standard lib. I need to bring in that library. Wow, what's there? Do you see why it's complaining?
No, but the linter is really messed up.
Did you save it?
Yep. Expected an expression. Good. Okay, we'll compile it. Let's see what it says. All right, and with you guys, to compile this, you just say make. Yo. I'm in the wrong. And you just say make, and it compiles. All right, and let me use it. And then it's gonna tell me that I need to pass in a file name there, right? And then if I passed in a file name, let's see. We have examples, and the first one we were supposed to do was print date. And it hangs, which means it's working somewhere. So let me kill it. All right. So we know it's going through. We're sending in the file name, and we can now work on that. Any questions so far on any of this? Okay. So we're receiving the conflicting. Okay. We sent it that CPU load, conflicting types for CPU load. Okay. CPU. It compiled, so I don't know why it's complaining. Anyway, let's open the file. And to open the file, we are going to use the file struct, grab a pointer to the file, and open it. And then you can give it to a mode of write or read. Since these instructions, we're not going to modify them. We're just going to give it a write mode. And then we're going to give it a buffer of, since we're going to be reading each line, like the way you explained it. So we're going to give it enough memory for each line to scroll the whole line. So we're going to give it a buffer of 256. That's what I gave it. You can give it anything you want. And then we're going to start at an address. Do we have a starting address? Yeah, we do. So we're here. So we can move that. Okay, we can just comment that out. Okay, and that out. Before I start using this file or doing any of that, I need to print this. I want to make sure that the print statement is working before I go further. And to do that, I'm going to do it here. Right. Also, you remember those headers we set here? These ones? We need to initialize them. So what I'm going to do, I'm going to initialize the since I've already got the struct CPU, I'll just use it.
PC.
I'll initialize it to 0. And then I'll grab the RAM. And I'm going to use a method called, this is like a fill in JavaScript. Whenever you fill an array with values, in C, we're going to use the memset CPU, and it's going to fill the array with the size of the CPU with zeros. So here we fill in the array with zeros. So we're going to do the same thing for the registers. We've got those two arrays. These two. The second thing is it's saying MSET is not important, so you need to bring in some libraries here. The first one is we need to include the standard IO. The second one we need to include
Standard lib.
Yeah, standard lib. And the third one, the MSET uses the string library. So we need to include it. And after that, if you go back to it, the error message is gone. Okay, I think that's why it was complaining at some point. Anyway, but all the errors are gone. All right. Yeah. All right. The second thing is we're gonna go here to get the value of the instruction. So we're gonna give it an unsigned character. We're gonna give it instruction register. And this is gonna come from, all right, did you guys implement the function of reading the, let's see, did we do that? Okay, so I'm gonna implement a function called ramRead. Just gonna be a function that's gonna be reading it's just going to be a function that's going to be reading like the program from those operands. So we're going to read the CPU. I'll pass it in the CPU struct, and then I'm going to use the program counter to read off that. So I need to implement this method. So on top here, I'm gonna say, since it's returning an unsigned character, and it's taking in the struct CPU, and then it's also, I think, taking in the instruction itself, and that's unsigned, right?
Mm-hmm.
Yeah. I'm going to address. And once it reads that, it's going to return whatever the address of the RAM. Okay, so why is it complaining? Okay, we are passing in a pointer to the struct, and I think we define it as CPU. And I forgot that. Okay, so this is going to be reading from the RAM. To write to the RAM, we'll just do something similar, and we'll call write to the RAM. And this is going to return nothing because we are just writing to. So, and since we are writing, we have to pass in a value. Like that.
Mm-hmm.
So we have to call it right. Okay, makes sense?
Mm-hmm.
Any questions? And I'm gonna do the same thing I did with the other functions. So I'll do something like this, to where I define my functions like CPU, read, RAM read, and CPU, RAM, right? And I know the write. Okay, that's correct, but I know the read, reads in, and wait. Yeah, it returns an unsigned character. And it receives an address. And the write receives in an address and a value. Okay, so that's defined. Is anybody copying that? Or you got it? Okay, let's go back to that.
So is CPU RAM write not returning? Oh, it doesn't return. Okay.
It doesn't return anything. It's just writing to the RAM. So you're going to be reading from the RAM using this method and writing to the RAM using that method.
Okay.
All right. So then once we have that, so we can just use it here to read and write, right? And here we're just reading. So we pass it a program counter. Now the way this has been set up is we are going to pass in the instructions for the main instructions. And then the next thing, we're going to pass in the operand A, the slot I was talking about. And then we're also going to put in the operand B. So here we're going to read the instruction. We're going to do something similar like that. So the instructions are going to be here. And then we're going to read the operand, which we'll call A. If you look at let's look at this. So here, you're going to be having like, this is the instruction. Then you'll be able to read the first operand and then the second operand. And then you go to the next instruction. You're going to read the first operand. And this one is going to have just one operand. And this instruction has no operand. Now, how do you tell how many operands the instructions have? It's this one right there. So if you look at these two, like I was talking about earlier, if you have the one there, that tells you I've got two operands. But if I have a 0 and 1 after that, that tells me I've got one operand. And if I have 0 in these two slots, that tells me that I have 0 operand. So you see that part I was talking about, like reading the operands?
Mm-hmm.
This is how you're going to be telling how many operands are there. But
that's not confusing at all.
wait, no, you just look at that spot. So like,
I get it. If it has a 1 in the beginning, it has 2 below it. If it has 1 after, I mean, if it has 0, 1, it only has 1, and if it has 0, 0, there's nothing. Okay. But they could have made it simpler.
all right. But so we can still read that stuff because this is going to be repeated all the time. So we might as well just read this too. We know the maximum reads are going to be 3. That one, this one, and that one. But we can, as long as we deal with this and that one, and then we make the right move, we can reread and reuse the instructions right here. We can reuse the variable IR and the operand A and the operand B. And the only changes, the instructions are gonna make 0 movements. The operand A is gonna make 1 movement, and the operand B is gonna make 2 movements. Okay. Once we have the instructions, now we're going to do a switch. And this is where the instructions are going to be compared. You're going to tell which instructions do I have. And that's good. These other instructions are going to go in between there. And we'll say, what if it's, since we've defined all these, if it's add, we'll do whatever that is, but we don't have that yet, so we'll just do a print for now. And we'll say print 8. Printing 8 manually. All right. Now, because this is going to be reading the stuff all the time, we're going to put in a case to where there's an error. Just once you print that, we're going to move the program counter by because the print has only one instruction, we're gonna move it by 1, by 2, because there's instructions on the operand, whatever you're printing. Otherwise, if something wrong happens, like you don't know what to do, you just need a default case. And this one is going to catch anything that it doesn't know what to do with. And this one is just like 2 spaces, and it's an X, because these are going to be in X. Okay. And you're going to tell it the PC counter where it's pointing at and the instruction itself. And once you get that, you're just going to kill it off. And I think we can test this. I think we've set up everything. And you just say make. Okay, so we did do something. Reference from standard print, not found for architecture. Print F. It's changed it for me. Break.
Line 86, should it be accumulator, like plus equal?
Yeah, yeah, and yeah. What was that? Yeah. And even here, that's supposed to be printf.
Oh yeah, this format.
Okay, there we go. And then we can just run that. Okay, so unknown instructions at there. So that means it's coming through, but it doesn't know what to do yet. So let's see. What other instructions are here? Okay, so once you set this up like this to where this is there, so it's going to be catching any errors you get. And if you get this message, that means everything is working and you haven't done one of the instructions. And if you go to like the top, you're going to see that we have the load right there. So we don't have it here, so we need to implement it. And that's how you're going to be doing for all of them. So we know we don't have the loading, and then the loading is going to be LDI, right? And what does the load do? Let me,
something with register.
for now, I'll just print something. We are here about to load. And then we're gonna kill it off ourselves. Actually, since we have this one here killing it for us, let's just keep going. And that one, and the, yep. Oh, I have to make. You keep doing making and testing it. So it's reaching that. We're about to load, and then it goes to the another instructions. So it says, I don't know what to do. And what instructions are we missing? Okay, so I know load has 2 operands. So I need to move that program count at three spots, like that. And I know print has 1, so that's okay. And what instructions? This one? Oh, so I moved it wrongly. That's why it didn't know what to do. Okay, so you see how I'm working with this? So I'm using the code I'm given. I'm looking at it. I know the instructions are on the right. I'm seeing how many spots I need to move it. Once I implement one instructions, it fails because I haven't done something else. So it tells me that spot right there, the hot. And then I come back here, I just copy, and then I paste. So I know the hot method doesn't move the program counter. And like that. And then I would say something like, in the hot method, is that correct? And then what did I make that mistake again? Oh, yeah, so it should be good. Do you see there? Why is it highlighting that?
Line 88 is HLT, yes.
Okay, so we have this while running, so this is gonna run forever. So in order to hold the program, we're just gonna make that from 0 to 1, or from 1 to 0. And once we do that, this is gonna stop. And if I run the program make again, and then run it, so it's gone through. We're about to load, print 8 manually. I'm in the hold method. So I've done it like just using the printf statements here, but the only one we've implemented properly is this one. So I don't need that print statement, but we need to load this. What do we need to load? We're gonna make the register, which is the one in operand A to equal the operand B. Does that make sense? So we're grabbing whatever the operand A is, we put it here, and then we equate it to whatever is that operand B. What about printing? to print, we're just going to print out, we know it's a decimal. We're going to print out whatever is at operand A. So just with this, the rest are just going to be repeating this way of doing it. And if I run this, okay, we did not do that. You get to print the 8 there. See that? So if I wanted to do multiplication, what do I need to do? I need to grab this. Actually, I'll use this one because it's closer to multiplication. This, paste it in, and I know multiplication is going to be multiplying like that. So what I'm doing is it's like I'm grabbing x equals to 3, and then I'm doing something like y times equals x, or like this. So it multiplies itself, you know. So whatever the x was, and then it multiplies whatever is on the right. And then I'm gonna call it mount. So add, you're just gonna copy that, paste, you're gonna add it. And since it's addition, you're just gonna add that, you're done. But we have a problem, we don't have multiplication and add, I think. So we're gonna go here, multi, did I spelled it wrong? And then I'll define it. I'll define the add. And what's the add? Do you know the binary for the add? And I'm done. So the last thing is now to replace this hard-coded thing with whatever the file you were reading. And as we knew, we were grabbing the file pointer, having kind of like a buffer that, so we're going to read the file one line at a time. And then I'll just use the method. I think he did show us in class. So I'll replace all that stuff. I don't need it. And I'll need an address. And I'll start reading the files. And to read the file, you first check if the pointer is not null. If it's null, you're going to throw an error there. And then it's going to say can not open file. And then you're going to give it a file name. And then you're going to exit. I think that's the first exit we got. I'll just give it to, I think I've got an exit somewhere else. This one we were using in this here, so we don't need it there. So I'll kill it there. And just to test out the file thing, I'm gonna kill it here on 3. After I print F reached here. And I'll test it out. Okay, that seems to work. I'm gonna give it a bogus file. And then it says cannot open file examples print because it's bad. But if I give it a valid, it says reached here. So I know I'm reaching here. And then once I'm here, I'll start reading the files. And I'll store them in RAM. Okay, that was just for testing, so I'll remove that. And I'll use a method called string to line to read one line at a time. And then I'll solve them as a byte. And every time I read the line, I'll put it in the buffer we created on top. And then I'll pass an optional, I can put a now value there, but I'll pass in an end char like he explained in class so that I can ignore spaces and bad characters. But I need to initialize it here. And then I'll pass it in like that. And then use it to ignore empty lines. So if end char is equal to line, I'll just continue. Otherwise, as I'm going through this, continues. I'm gonna be storing the bytes in our RAM. And I'll use the method of writing that we had. And each byte is going to be like an address. So we pass in the CPU, we started the address at 0. So we increase the address. And we pass in the value as a byte. And if all is good, why is this complaining? Did I miss something? Ah, wait, was I supposed to read all? Yeah, I wasn't reading the line. I need to read the lines using fgets. And passing in the pointer. And making sure that, read all the lines until it's now, then we know it's over. And as we're doing that, yeah, that should be good. Do I have an extra? I was thinking that's, yeah, that's an extra one. Okay, so wait. I'm missing something. Oh, okay, there we go. Now we're gonna read it like straight from examples. So for example, if we have, let me make sure, yes, okay. So if we have a byte file, it tells us we can open that byte file. But if we have like a good file, it's gonna do the instructions we've given it. And we can also do multiply right now. It multiplies. And then we can add, I think, or we don't have addition. Any questions so far? Wait. Oh.